In this exercise, we're asked to find the number of positive and negative roots, or real zeros. And we can do this by using something called Descartes' rule of signs. Now, Descartes' rule of signs says that we can take the sign changes, in this case of h of x, could be f of x, and that would give us the possible positive roots. And now what we find in the sign changes, we can subtract 2 from that. So we got different possibilities, and I'll try to go over that in a moment. And then for the negative roots, we can take h of negative x. And then we, again, count the sign changes, and this would tell us how many negative roots we could have, less 2 as long as that number stays greater than or equal to 0. So first let's start on and the reason why it's the less 2 is because if I have any imaginary roots, they must come in pairs. So there's got to be, I can't have just one imaginary root or complex number, complex root. It must be 2. So here I've got h of x equals 2x to the 5th plus x to the 4th plus 3x cubed minus 4x squared minus x plus 9. And how many roots can I have? Well, I can have 5 roots. Now, let's count the sign changes here in h of x. Well, positive, positive, positive. Okay, positive to negative, there's a sign change. Negative, negative, but negative to positive. So I can have 2, or subtract 2 from 2, that's 0. Or I could have 0 positive roots, positive real roots, maybe I should say. All right, now let's take h of negative x. And so what we're doing now in h of negative x, I'm substituting negative x for x into the function. Now here's a tip. If the function is being raised, and if the term, is being raised to a odd power, the sign's going to change. So think about this. If I had negative 2 to the 5th, let's say, well, negative 2 to the 5th is negative 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, and times, where's my hand? There it is. 2 to the negative 5th is negative 32. And so that's going to make, from a positive term, positive 2x to the 5th. And let's see, 2 times negative 32 would be negative 64. But what if I raised the sign an even number? In other words, I've got an even power such as negative x to the 4th. Well, the sign's not going to change. Because what's negative 2 to the 4th? Well, negative 2 to the 4th is going to be positive 16. Negative 2 times negative 2 is positive 4. That's squared. Negative 2 again, cubed, 4 times negative 2, that's negative 8, becomes a negative. But when I go to the 4th power, negative 2 times negative 8 is positive 16, and so the sign would remain the same. And that's kind of a shortcut in this Descartes rule of signs method of trying to determine what is the positive and negative zeros. Okay, so I think I've got this finally written out. So now I've got 2x to the negative 5th. Well, that's going to make this go negative. And I'm just not going to write the whole thing. I'm just going to write any sign change or sign to what my sign value is. That's going to be negative, right? We just went through that. It'd be negative 64 if it was 2. All right, plus negative x to the 4th. Well, the sign's not going to change because we raised it to a even power. But on 3 times negative x cubed, well, that one's going to change. Negative 4 times negative x squared, that sign is not going to change. It's raised to an even power. But negative x to the 1st, or negative x, which is negative x to the 1st, that will change to a positive. And, of course, my constant's not going to change. Now, how many sign changes do I have now? 1, 2, 3. I've got 3 sign changes, which means that I can have as many as 3 negative real zeros, or less 2. I might have 1 negative real zeros. All right, now let's think about what I have. I can have up to a total of 5 real zeros, right? Well, if I have 2 positive and 3 negative, well, that would be 5, and so I might have 0 imaginary. But what if I had 2 positive and only 1 negative? Well, 2 and 1 is 3, so there I might have 2 imaginary. Or if I had just 3 negative and no positive, I could have 2 negatives, right? 3 and 2 is 5, imaginary, excuse me. If I had 3 negative and no positives, well, then I would have 2 imaginary. But what if I only had just 1 negative and no positive? And I got to have 5 zeros. How many imaginary could I have? 4. So I can have 4, or I may have 2, or I may have 0 imaginary real zeros. Now, fortunately, they didn't ask us to factor that and find the zeros, but later they will. So here again, what's the recap? I could have 2 or none positive real roots. I might have 3 or 1 negative real zeros. And then I could have either 4 or 2 or 0 imaginary real zeros. And all of that I could determine using Rene Descartes' rule of signs. So here's the thing. When I go to the h of negative x, if the exponent is odd, it's going to change the sign of the term. If the exponent is even, the sign of the term will remain the same. I count the sign changes, take that number, less 2, all the way down, as long as I don't go below 0. Those are my possibilities. And in this case, it was 2 or 0, 3 or 1, and then 4, 2, or 0 imaginary. 2 or 0 positive, 3 or 1 negative, 4, 2, or 0 imaginary.